Single image depth estimation, or SIDE for short, is the task of predicting per pixel depth using a single RGB image from a monocular camera. It is a fundamental problem in computer vision with applications in several domains such as robotics, autonomous driving, and augmented reality. This new model, called as Echo Depth, is a SOTA diffusive monodepth model. It is a new side model using a diffusion backbone conditioned on WIT embeddings. It's the new state of the art in the single image depth estimation. It is a novel model for MDE in a side task, WIT embeddings to provide semantic context, and it performs really good when it comes to zero shot transfer task. It has up to 14% more grunt than the previous SOTA models. The problem which we are trying to discuss here is typically formulated in two flavors. First is metric depth estimation, or MDE. Then the other one is relative depth estimation, or RDE. As both of these names suggest, MDE deals with estimation in physical units such as meters, whereas RDE techniques focus on relative depth only and require a per image affine transformation as post processing to convert to a physical unit. Conventional geometric techniques for depth estimation typically rely on feature correspondence, parallax, and triangular from two or more views. The problem becomes ill posed for estimation from a single view. Intuitively, depth map is a 3D representation of the scene, whereas an RGB image is a 2D projection of the scene. So it cannot be uniquely determined from a single RGB image. That is why learning based side models rely on visual cues like shape from shading and other contextual priors for pixel depth prediction. A data driven approach makes the side pipeline simpler but also makes the learned model dependent on the quality of training data. And that is where this model helps a lot. Let me show you a video that will explain this concept much better. Now in this video, you can see the model in action, and it is capturing all the intricate details with very high precision. Look at both the images. The car is driving on the left, and all the metric depth estimation is being captured in great precision on the right. You can also check out all the trees, sidewalks and all that stuff, and it is absolutely awesome even when the overtaking, all the shapes and details are there. How good is that? Now, going back to the architecture, if you look at this architectural diagram, it is also pretty interesting. So what is happening here is that the latent representation of the input image undergoes a diffusion process, which is conditioned by their proposed side module. And within the side module, the input image is fed through the frozen WIT model. From this, a linear combination of learnable embeddings is computed, which are subsequently transformed to generate a 768 dimensional semantic context embedding. This embedding is then utilized to condition the diffusion backbone. Subsequently, hierarchical feature maps are extracted from UNet's decoder, which are unsampled and processed through a depth regressor to generate the depth map. How good is that? And then I will also drop the link to their paper where you can check out various qualitative results across four different data sets. And let me show you that too. Now have a look at these qualitative zero shot results across four different datasets. It is demonstrating the zero shot performance of their model trained only on the NYU V2 dataset. Corresponding qualitative results are presented in above table, which you can check out here. And there's a lot of detail there on different benchmarks which you can read through. Now, uh, the first column here, you can see it is representing the RGB image on the very left. The second column depicts ground truth depth, and the third column showcases their model's predicted depths. Additional images are also available if you're interested from this project page, and I will drop the link to it in video's description. But all in all, I think a real groundbreaking project, and you can find further detail about its paper, supplementary code, and a lot of other stuffs here. So I think this IIT Delhi really has done a good job, and it is good to see that more and more research is happening in different parts of the world. So really hats off to all of these guys, Suresh Patni, Radhi Agarwal, and Chetan Arora. Wonderful work, and I would highly suggest to read through this paper. That's it, guys. I hope that you enjoyed it. Let me know if you have any questions or thought. If you like the content, please consider subscribing to the channel. And if you're already subscribed, then please share it among your network as it helps. Thanks for watching.